Hey guys, here's another video to help you out with this section where you have the various types of segments associated with circles. The problem with this one that makes it a little tricky is this time the two segments meet outside the circle. So kind of like when we did all the angle stuff, we had in, out, and on. Well, in the previous video we had where they meet inside. Here's where they meet outside. But they're not chords. This time they're secants. So a secant-secant relationship for this example. And in the secant segment that's created here, you have a piece that's kind of like on the outside. I'll call that the external piece. That's the external piece. And then you have the whole thing, which is the secant itself. Okay? So you have an outside piece and the whole thing. And it turns out in this one, although it might be tempting to do the external piece times the internal piece, which kind of looks like the previous case, you actually have to do the external piece times the total. Okay? So the external piece times the total equals the external piece times the total. Look again. External piece, external, and EB is the total. EC is the external, and ED here is the total. So if you could just remember oops, sorry, that got cut off. If you could just remember external times total, that'll not only help you with this case, but it'll actually help you with the last case, which we'll get to next. Okay, so all this basically means is when you have a secant-secant connection, then the external times the total equals the external times the total for each secant. Alright, let's see how that works in action. Here, I'm going to identify my external, that's my 6, and my total, while you might again want to use the 10, it's not just 10, it's 10 and 6 together. That's my total. External here is 8, of course. My total here, don't get confused, just because there's an x there, it's still the total. It's not 8 times x, it's 8 plus x. 8 plus, just like here, we didn't multiply 10 times 6 to get 16. We did 10 plus 6. Little plus little make big. Little plus little make big. So according to my pattern, I'm going to do external times total. External is 6 times total is 16 equals external is 8 times total is 8 plus x. And there's my setup. Okay? 6 times 16, that's just straight up, no big deal, 96. This is 64 plus 8x, don't forget to distribute. Subtract 64 from both sides, and I think we're home free. Looks like x equals 4. Okay, so again, external times total, external times total, the whole thing. External, 6, total, 15. External, 5, total, 5 plus x. Alright? You start seeing it, if you recognize this quickly, you'll see external, and then of course you just, in your head, you can do the total, or you can write it out, whatever works for you. Oops, 5 plus x. And that takes care of that total, and it's really just like this one. Okay? So that's 90, that's 25 plus 5x. That gives you 65 here. Oops, 65. 5x, so x equals, looks like 13. And that pretty much is that whole case. Okay, yeah, again, the algebra can get a little more tricky, but for the most part, if you just recognize where they meet, right, this time they meet outside, remember external times total, and it'll get you through every one of these kinds of problems. Okay, good luck with that kind, and I'll make one more video for the last case, and as always, let me know if you have any questions.